Hi guys, my name is Mr. Lead. Today we're going to be looking at the topic of geology. Now, geology, by the way, is a topic that I have quite a bit of experience in myself. I actually once worked as a paleontologist. I can talk more about that when we talk about sedimentary rocks. But you might be wondering first, what is geology? Geology is the study of rocks and rock formations. Okay, but why would we bother learning about rocks? What's the good? What's the benefit about learning about rocks? Well, there are three main benefits that I'll bring to you. The first benefit is when you learn about rocks, you know where you can find certain resources. It benefits you for mining. For millennia, people didn't care about geology. People didn't study geology, but it wasn't up until the 1600s when people started working out, hey, you know those precious minerals and metals that we like to find? Did you realize that some metals and some minerals are more likely to be found in certain rocks and certain rock formations as opposed to others? Oh, really? So that meant that all of a sudden there was value in learning geology. There was value in mapping out mapping out, say, your entire country to know the different rock formations and the different patterns of rocks you would find there. And then the more people learned about different rock formations, the more fossils we found. And that's the second main reason why we learn geology. We get to learn about we get to learn about prehistory and all these animals that are now extinct. This is Mary Anning. She's one of the founders of paleontology. And paleontology, by the way, is the study of fossils, or a paleontologist is someone who finds dinosaur bones. But anyway, she was one of the founders of paleontology and one of the first people to actually discover dinosaurs. There's a really good story about her we'll get into someday. Lastly, it's good to learn about geology because you'll be able to predict erosions and catastrophes if you get to know the rocks around you and the rock formations around you better. There's a famous analogy in the Bible that says a wise man builds his house upon a rock. And that's totally true when it comes to talking about your faith. But when we're talking about rocks, you've got to put an asterisk there because only certain rocks are actually really good to be building on. Then you don't want to build your house on any rocky formation. So let's first talk about the structure of the Earth. This is what we know to be how our Earth is structured. Our Earth has different layers in it. The very top layer is only about 70 kilometers deep, and this top layer is known as the crust. Below the crust, we get the mantle, and then the core. Now, the crust, think of that as solid rock, all right? Then the mantle, that is where we start seeing molten rock, molten lava and whatnot. By the way, the difference between lava and magma is that magma is below the Earth and lava is above the Earth. So this would technically be magma because it's below the Earth. Anyway, how do we know though what are the different sections of the Earth here? Well, the way we're able to find that out is if you saw an earthquake appear here, or if we made an explosion appear on one side of the Earth, and we had all these sensors on the other side of the Earth, then the waves and the ripple effects that come from that explosion will be felt on the other side of the Earth, but they will only reach there at a certain time and with a certain magnitude, depending on how they have where they have to travel through the Earth. And so we've been able to use this sort of data to work out, there's clearly some sort of really thick layer deep in the Earth that's slowing down the waves of these explosions, which means that we suspect that the Earth's core is made up of mostly iron and nickel. Now, what is the difference between a rock and a mineral? Okay, so we've discussed what minerals are when we talked about chemistry. Minerals are when you see a repeating lattice of an inorganic substance, say, for example, salt or fluorite. And so this is what a mineral looks like. A rock, however, is when you get lots of minerals put together. Okay? Now, people mistake rocks and minerals all the time, so I'm going to say this again. A mineral is just one substance. So this here is quartz. All right? We're just seeing, if we were to look at what quartz looked like on the atomic level, we just see a lot of a repeating lattice. A rock, on the other hand, is made up of lots of different little minerals. You can see every one of these specks is a different mineral. Rocks are made of minerals, and minerals are just, minerals are what rocks are made of. Okay. Now, when it comes to studying geology, there is a lot of guesswork involved in geology, unfortunately. This is because there's only so much we can observe. For example, the structure of the Earth I just explained to you there, there's a bit of guesswork involved there because we're basing that off of some secondhand information we're getting from earthquakes and whatnot. We can't actually even dig that far down into the Earth. So I mentioned before the crust of the Earth is 70 kilometers deep. The furthest we've ever been able to dig is about 12 kilometers deep. That's because the further you go down, the hotter it gets. Not because there's molten magma or anything. The magma is way far down here. We're only able to just penetrate a little bit of this crust here. So there's so much we're still yet to see. And then there's the question we have to ask about how is it that rock formations have formed the way they have? How would we know that sort of thing? And again, there's a little bit of guesswork involved here as well. But the way we're able to identify how current rock formations have formed is by observing the way we're able to identify how past rock formations have formed is by observing how current rock formations are currently forming. We are able to see some processes occur in geology where rock formations are constantly changing. We're seeing weathering, avalanches, landslides. We're seeing depositions. We're seeing all of these different processes, and we're going to go into a little bit of detail about them in a moment. But what you've really got to understand here, really key thing, when you think about geology, when you think about, say, biology, like the study of life, you think of that biology as being full of change. We're seeing new species come and go all the time. We're seeing species die out all the time. We're seeing new ecosystems growing and dying out. We're seeing plants grow and die. We're seeing change occur all the time in biology. What you have to understand is that geology is, even though they're just rocks, you might think they stay the same all the time. Geology is also full of change, all right? So the very first change I want to talk about is how we see change in rocks. There are 3 different types of rocks, and they make up part of what we know as the rock cycle. We see these different rocks often change into each other if they're given a very long enough period of time. We see, we're going to talk more about each of these rocks in further detail, but let's briefly cover the rock cycle. Igneous rocks, they're made from magma. Okay, so when you get magma cooled down, you get an igneous rock. That's like this. But if the igneous rock breaks apart into tiny little pieces, so this is my igneous rock. If it breaks apart into tiny little pieces like this, I'm spilling rocks everywhere now, then you call those sediments. And when those sediments eventually fuse together, so we get sediments and they fuse together into a bigger rock, that's called sedimentary rock. And when you see igneous rocks or sedimentary rocks and put under extreme pressure and heat, they will undergo great change. And they'll change their appearance, going from, say, looking from like this to this. They're called metamorphic rocks, okay? So igneous rocks come from lava. Sedimentary rocks come from little bits of sediment. And metamorphic rocks come from change, because metamorphosis is change. Metamorphosis is change. All right, let's talk about more geological processes. Weathering. We're seeing weathering occur all the time. Weathering is where we see the breakdown of rocks into smaller ones. So we often see we often see, say, different land formations being constantly broken apart, and this can just be due to the wind, or say temperature changes, or if we see lots of water hitting it, or lots of ice, or if we see lots of salt hitting certain features, we see rocks break apart. We're seeing this currently with the 12 apostles. When the 12 apostles was first discovered, it was called the 12 Apostles because there were 12 of these monumentous landmark rocks that were just sticking out from the beach. Now, there's only like 7 of them, and that's only over the past, say, 100 years. They've been slowly weathering away until there's nothing left. We also see chemical weathering. This is where we see, say, the soil and other chemicals within the rock will crumble, and we see chemical weathering when we see a color change. Say we see a bit of rusting in the tiny microscopic iron particles. And we could also see biological weathering, and this is where we see organisms that have actually split apart rocks. This is pretty rare, but you can actually see trees growing up and splitting apart rocks. All right, another type of a natural process, erosion. Erosion is when we describe the movement of weathered rock, okay? So once you've got some of these weathered particles, erosion is when we see them being moved away. So we see, say, wind, water, or ice, or gravity. They're all things that can help move these weathered particles, okay? We can call these weathered particles just sediments. All these sediments are just being moved away by wind, water, ice, or gravity. And so this is what happens when we see at banks here. These banks have been weathered down so much that we see erosion. We're seeing the water sweeping away all the banks on riversides. All right, deposition. Deposition is when we see material that's actually being carried away by erosion and just being dropped somewhere else. So, for example, we've seen now on these riverbanks, water is carried away the rocks because they've been weakened down by weathering. Water's carried these particles away, and it's now going to dump them somewhere else. So this water is carrying the particles away, and it just dumps them on the banks here. So this sand here is examples of deposition. This sand here started out as rocks that were from further up the creek or further up the river. So if you say have up the top here, if you say have I don't know feces or like something really disgusting up here, that's going to end up being deposited further down the river. Lastly, another process that we're going to talk about is compaction and cementation. So this is the way that sediments and sedimentary rocks can be made. The way we see sedimentary rocks made is like this. You start off with sediments like this, and then when you've got a whole lot of those sediments all put together, I'll show it like this. You start off with the rocks like this, like that. Then when you see them compacted together, over time, that's what's called compaction. And then after that, you'll see cemented minerals squeeze into the gaps of these compacted sediments, okay? And so these cemented minerals will eventually crystallize and undergo chemical changes so they crystallize and form a full rock like this. So this here, we see some rocks that were originally loose sediments, they were big rocks, but they've been compacted together, squished all together, and then some tiny little sediments have squeezed in the gaps and undergone chemical changes to cement these bigger rocks together. All right, that is how a lot of sedimentary rocks form. All right, the very last thing I'll talk about is melting. Basically the opposite of crystallization. The opposite of crystallization is just when we see melted rocks or form solid rocks, or if we see crystallization is when we talk about the formation of solid rocks or minerals. Melting is when we see these rocks melt down. And melting is really key because with melting, we can take igneous rocks and rearrange them to become something totally new. And we can do that for all types of rocks. We can do sedimentary rocks and melt them down into something new. Same for metamorphic rocks. Okay, so that's an introduction to geology. I hope you learned something. Thanks for watching.